Hello, my dear friends, my dear viewers. Welcome to my channel, PCM Guru Bro. In the earlier videos, when I have taught you the Kirchhoff's first law and second law, here is a new question which is asked in the competitive examinations, in the board exams also, which is involved in chapter 3, current electricity, page number 19 in the NCERT text, in the section 3.14, example 3.8 and figure 3.26. So by revising our first law, Kirchhoff's first law, we have a Wheatstone bridge over here. In this question, by showing this figure, it is asked, calculate the current through the galvanometer when the potential difference of 10 volt is maintained across AC. When a potential difference of 10 volt by the source battery is applied across AC, calculate this galvanometer current. So this Wheatstone's bridge Ig is not 0. That means this is not balanced Wheatstone bridge. Thus, there is a galvanometer resistance over here. So we want to find out Ig. In this mesh, we will revise the first Kirchhoff's first law. That means the junction rule. The I is converted into I1 and I2 at A, and this I1 will go to the B point, where this I1, from this I1, G is gone. Ig is gone. The current Ig is gone from I1. The totality of I1, Ig is gone. So it is written over here from over the BC section, it is written the whole totality minus which is gone, Ig. It is okay. Then here, this I2 will go over here and it will get mixed with the Ig coming from here. So it is named I2 plus Ig. So this I2 and I1 again will get added up. This minus Ig and this plus Ig will cancel up and will again yield the I. So by the junction rule, by the point rule, Kirchhoff's first law, this is okay. Then when we are going to the second law, we want to take every mesh now. Here I will discuss the mesh BADB, BADB, and then BCDB mesh, and again ADCEA mesh, ADCEA mesh, ADCEA mesh. The left triangle, the right triangle, and this whole thing. So when taking the BADB mesh, BADB, I have earlier taught you in the class that there is no battery over here, so we'll leave it. Then the current, the basic current is taken as minus. So I1 is taken as minus. I1 current in the positive direction. This thing now, the positive current starts from here, and let me take this I1 as negative. First of all, for convention, I1, the naming, the top part. Minus I1 into 100. Then the same direction now, minus Ig into then counted 15. Then against this I1 and Ig comes this I2. So plus I2 into 60 ohm, which is the encountering resistance. This is the basic thing which I have taught you. Again, it can be written in another form, which is also in some classes it is discussed. Just multiply by minus 1, so that you could yield this minus 1 plus this minus Ig plus Ig. This I2 will become minus I2. So it is okay. Then we can write it easier way, 100 I1 plus 15 Ig minus 16 I2. This whole thing is a multiple of 5. So this dividing by 5 over the whole equation. So 100 divided by 5, 20, 15 by 5, 3, 60 divided by 5, 12. So this is the first equation in the NCERT text. That is 3.84a. That's the equation in the NCERT text. Then BCDB mesh. BCDB mesh. Then first of all, I will say along the I1 direction, I1 minus Ig. So this minus of I1 minus Ig into 10. Minus of I1 minus Ig into 10. Against this I1 minus Ig comes this I2 plus Ig. So minus I1 minus Ig. Then this plus of I2 plus Ig into the encountered resistance 5. Along this, again this current also comes. So this is acceding with this current. This is the same direction. I2 plus Ig have the same direction of this Ig. So this will also, along with this plus Ig into 15. This is along the same direction. This is in the opposite direction. This is given minus. These two are given plus. Okay. And we can write it another way. Multiplying minus 1 into the whole equation gives plus I1 minus Ig into 10. This plus become minus, this plus become minus, this equation. Then opening the bracket, 10I1 minus 10Ig minus 5I2 minus 5Ig minus 15Ig. Okay, opening the bracket. And then we can sort out what all is there. Minus 10Ig minus 5Ig minus 15Ig. 15, 5, 10. That means 15 plus 5, 20. 20 plus 10, 30. Minus 30Ig. What is left? Minus 5I2. 10I1 minus 30Ig minus 5I2. This whole thing now, when it is divided by 5, gives 10 divided by 5, 2. 30 divided by 5, 6. 5 divided by 5, 1. That's the equation which is given in the NCERT text. Okay. Note it, and then comes the ADCEA mesh or loop. ADCEA mesh. So that includes a battery. I have taught you earlier. Let us discuss again. Take this I2 as positive. This ADCEA mesh 882 minus I2. This is the starting current now. So apply, first of all, I said when a cell is encountered, give it positive value. So plus 10 will be written first. That is written over here. Then comes the first current I2, which is conventionally taken. That is, I'll give minus over here. Minus I2 into 60 over here. Same direction comes I2 plus Ig now. So minus I2 plus Ig into 5. There is no other thing over here. This is the key. No other thing is over here. So plus this minus I2 into 60 ohm minus the whole I2 plus Ig into 5 ohm plus 10. That's complete. Multiplying the whole by minus 1. Then this minus will become plus 60 I2 plus 5 into I2 plus Ig plus 10 becomes the minus 10. Okay. Multiplying the whole by minus 1 along this whole equation gives this. So opening the bracket over here, 60I2 is written over here. 5I2 plus 5Ig is equal to 10. Okay, look over here, I2. This is 60 plus 5, 65I2 plus 5Ig is equal to 10. This dividing the whole equation by 5 yields 65 divided by 5 gives 13. 5 divided by 5, 1. 10 divided by 5, 2. This is the equation in the NCERT text. So for solving these three equations now, 3.84a, 3.84b, 3.84c, we will do some process, which is 3.84b into 10. I will write 3.84b. That means 2i1 minus 6ig minus I2 into 10. Again, that will yield 20i1 minus 60ig minus 10i2. That will give an equation 3.84d. Okay, that means this thing, this thing, leave it over there and we can solve this. Look at here, 3.84a. There is 20i1, no? I am bringing it, this i1 to 20, no? By multiplying it by 10. So I will write a process in which we can eliminate this i1. So 3.84a, the whole equation, minus 3.84b into 10. This is the whole thing. No, we can minus this, both equations, 3.84a minus the whole 3.84d. This is it. So we can write, first of all, 3.84a written over here, 3.84b into 10 written over here. Okay, by minusing 20 minus 20, 0 I1. Leave it. This is cancel out. This is cancelling out. Then this minus over here, will get plus over here. This minus over here will get plus, and this we can do the operation. 20 minus 20, 0. 3 plus 60, 63, minus 12 plus 10, minus 2i2 is equal to 0. Then this minus 2i2, when it is taken right side, 2i2, then 63ig is equal to 2i2. Then divide the both side by 2, then 31.5 ig is equal to i2. That means i2 is equal to 31.5 ig. This I2 is substituted in the equation 3.84c. What is 3.84c? 3.84c is 13I2 plus Ig is equal to 2. It's written over here. This I2 substitute over here, isn't it? I2, 13 into 31.5 Ig plus Ig is equal to 2. 30 into 31.5 is equal to 409.5 Ig plus Ig is equal to 2. This 409.5 plus 1 Ig, that means 410.5 Ig is equal to 2. Ig is equal to 2 divided by the whole 410.5 is equal to 0.0048721 ampere. This is a big value, ampere, in the range ampere now. So conversion of this ampere into milliampere. Now 1 ampere is 1000 milliampere now. So 1 ampere is written over here. Then 1 milliampere is 1 ampere divided by this 1000 ampere. This is written over here. So we can just write this whole thing, into a somewhat a precise form. That means this whole thing into 10 raised to 3 gives milliampere. So 4.0048721 into 10 raised to 3. That means this ampere into 10 raised to 3. That means the whole into 10 raised to 3 gives 4 point. That means 3 zeros are there. Now this whole thing into 1000. 4.8123. 4.8721 milliampere. Study all these conversions. Any doubts are there, call me. I'll be very happy to clear all your doubts. Bye. Please like, share and subscribe my channel. I'll be with much more interesting competitive entrance oriented questions also. I will make you understand the very easiest manner. Please do share, subscribe and like my channel. Bye.